Welcome to a special Autogefühl feature on 3D printing with Thomas. And I got a guest today, it's Bruno Alves. He's a specialist at Ford for 3D printing, and we're going to talk about what's happened so far, what are the current methods, and what can we expect in the future. And for starters, we also got special footage films from Ford. Let's see how this technique is being used. There's one technique for the start, how to produce tools from 3D printer. Let's go in detail on that, and then we'll talk about this kind of method.
3D printing is a process that's also known as additive manufacturing, where a solid CAD model is sliced into very thin layers digitally on the computer. That data is fed out to some sort of machine that will produce that layer one at a time, additively, and grow the part up. So you're printing one layer on top of another layer to grow a three-dimensional part.
Well, Ford uses 3D printing because it gives us a lot of advantages in being able to create something right away. We can do many iterations all at the same time. We can come out, engineer can say, I've got some ideas, I've got 5 or 6 different parts, I really don't know which one I want. We'll make them all at once, and we'll make them all in a very short period of time. So they'll be able to put those on test and say, okay, this gives me direction, and now I'm going to make 3 new parts that are completely different than these, but it gave me the information. You can do that time and time and time and time and time again, and come up with a really optimized part at the end of the day. And that's all because of the speed that we can produce the prototype parts without tooling.
So we're literally taking something that took 16 weeks and taking it down to just a couple of days.
3D parts that we make for prototype go on every part of the vehicle you can think of. We cover engine, transmission, we've done every program within Ford Motor Company, North American and abroad.
These parts that are made using these additive technologies are very similar to the real parts.
The 3D printed parts out of sand, we actually make a casting, so that is basically identical to a production casting. You know, we're just using a different technology to make the mold than you would in production.
So we can do the real life physical testing. It holds up exactly to the way a production part would hold up.
We really didn't understand the potential of what the capabilities of this process was going to be. It's incredible.
So that was very interesting, and we are going to talk about this method here with Bruno Alves. We've seen it. As far as I understood, it was a technique where you have say like sand raw material, and then you produce a tool from it. So it's not that you're producing a certain part, you're using the tool, and then you can do the part with it.
Yes, we are talking about sand printing for tools. You have this kind of printing tools when you have a die casting where the tool is destroyed to get a part. So you can produce the part in sand printing, and then we will put aluminium or metal, and then you get the part that you need.
What is the advantage in doing it that way and not the classic way?
The advantage is that you are saving a lot of time, because to make a tool from sand you need a metal tool to make this. So, and if you print directly this tool in sand, then you are avoiding this cost for this tool, metal tool, and you are saving this time that you need.
So what can we expect in the future there? Because if you're doing classic tools, it has something to do with mass production. Is there, let's say, a certain figure, a certain number where you say from 1,000 parts it's worth to do the 3D printing method, and then 10,000 parts we have to do it the classic way? So where's the ball?
There's always a compromise between costs and timing and what really we want. So if the quality, if we are offering the quality that is not expected for the client, so we have to be a little receptive with this technique, because 3D printing is, we are seeing the parts like this, and we cannot compare these parts to mass production. You will not have all this detail that the mass production you have. This eye injection molding can deliver parts with the surface much more quality than the 3D printing. Nowadays, this is the best quality that we can get, but nevertheless, you still have these steps. So the 3D printing is a process that works with steps, and this is one of the disadvantages compared to traditional ways that you have injection molding, that you can polish the mold, and then you have sure that in the part remove it from the tool will be with the surface very, very good.
So from an engineering perspective, the creating of tools is very important.
Yes.
But from a design perspective, you can produce the final parts and then do some models like this here. I mean, it's Focus or Fiesta steering wheel.
This is from Mondeo, from Vignale Mondeo.
It's Vignale Mondeo. And we can see this is very interesting. Even the details like the OK button, you know, certain buttons, the icons on the steering wheel, these ones are even imprinted on there. And I've heard a nice story where you prepared a model and then the manager came into the model and ripped up the steering wheel because it was so real.
So real.
And so that's a true story.
Yeah, and you can even now feel it. If you put the steering wheel like this and the knob, if you close your eyes, you can really imagine that you are inside of the car. And this is incredible. And
Gear stick, by the way, also it's totally light, and of course you wouldn't put it in a real car, but for a model, for example, for a car show, or when you want to see how it looks like, it will do just perfectly fine. And this is not the method we talked about initially, so how does this method work?
so, regarding the quality or, sorry?
The production process, because initially we had the one which is kind of had this sand raw material, and then it was used for tools. And this
Yes.
one is now for the final design product.
Yeah.
And so, how does the method work here?
Yeah, this in this case, when we are talking about one or two parts, this makes sense because you are saving material and you are saving time. And all these two parts, they are built in shell, so we are saving material. It's completely so it's a shell, hollow part, and this, for design perspective, is very good. They can just polish, they can paint, and then you have a part more or less like you will have in mass production with a single tool. Of course, the costs, if we are talking about 1, 2, 3, makes sense. If we are talking about more, then we have to, as I said, there's a compromise, and then we need to change the method, production method, and okay, maybe we need a white tool. We call it white tool, is aluminum tool to make some small productions.
So whereas we have the initial method, we have like sand raw material, and the certain small parts are being processed and then getting stick. This one here, the difference is that it goes layer by layer. It's more closer to the traditional printing as we know it.
When we're talking about sand printing, is related to parts with metal that are intends to be metal. So the process that it is more or less like SLS. It's a selective laser sintering that instead of plastic, for example, PA, you are working with the sand. And then the sand with laser, they get together all of this then can make the tools. In this case, the process is the same. We are always working with layer by layer, thin paper layers, but the material is different, it's plastic. But the process is the same, the concept is the same.
So it's the same, we have a small 3D printer behind us,
Yes.
We have also filmed that one, how that one works, and this is the same process basically than this one.
The 3D printing process is basically the same depending if you are talking about SLS, SLA, FAM, is the same. You're working with three-dimensional axis, X, Y, Z. The difference, of course, then comes the process that works with resin, that the laser, the UV radiation that makes the resin hard, and then we have SLS that you have the powder, plastic powder that will melt it with the laser, and then we have FDM for example.
By the way, here's also for the Vignale, it's a model, and it would be at the side vents. It's kind of like a design part as well. And it feels actually kind of worthy, especially if compared, for example, to that one here, very light. This one is also light, but this one, I mean, like from the structure, it also feels like if you paint it, I would maybe accept it in my final car. And so I think this is also a crucial point. I mean, you're talking about it rather from a design perspective. Where is, the connection between design and engineering? Because can we sometimes expect that we'll also get the final product at the car?
Now we are going to a very sensitive point that the engineering side, that they make a lot of tests to the parts, especially crash tests, and of course with 3D printing. If they are thinking about making mass production with eye injection molding, and if we are giving to the engineer this part to make the tests in this part, we need to be a little careful that we are not talking the same parts. So they cannot perform the tests here and just close the eyes and then imagine that in the mass production the results will be the same. So there's always, the engineers needs to be very, very sensitive, and especially all the specifications from the material. This is PA, this is also polyamide, and imagine that in mass production will be PA, but we are not talking about the same structure. When in eye injection molding you inject the tool with 300 bars and all the connections from the molecules are much more different, like in this kind of part. So
how long does it take to produce these parts? Can you say this from?
Yes, this take 2.5 days, depending of the quality that you want. If you want this quality, is 2.5.
And the printer is running 24 hours.
Yes. If you print push the button Friday, next Monday or Tuesday you can have it.
Okay, and this one, how long does that one take?
This is more, of course, depends of the area, and we were a little clever in this, that the parts are built in shell. You are saving a lot of time and material, so that can take maybe 1 day to build this part.
And I think we also have a front grille here of a Vignale, and is this the kind of same material?
Yes, the same.
How long does that one take?
It takes also 2.5 days.
And I mean, basically, if you compare it to a normal plastic front grille, like maybe when it's painted, would the customer even see a difference?
This front Vignale grill is it's a very, very unique design that we built this for prototypes. It's the only option is to make in 3D printing process. If we try to mill this part, because we have also this milling process for prototypes, you cannot mill parts with this thickness. So and all these designs, these geometries. So and we were very clever to choose this 3D printing process to apply in this Vignale grill and save us a lot of time and the quality. It's very important for us as well.
When you're printing layer by layer, you can also do some fun stuff. For example, 3D car models, and you can even do them from chocolate or candy. Let's check out another feature film about that one.
We are 3D printing the new Ford Mustang in chocolate.
We made this 4.5-inch long Mustang out of plastic. We're also making the Mustangs out of chocolate and candy with one of our suppliers, 3D Systems. This is just a highlight that Ford uses 3D printing technologies to develop all of his vehicles.
We're really excited to be partnering with Ford on this. We got kind of a sneak peek at their new Ford Mustang, which was awesome. And it was a challenge to take it from the full CAD version down to a little 1-inch bite of chocolate. That was fun.
We got the design from the design studio. This is basically the brand new Mustang, 2015 Mustang, that we're going to replicate.
We're printing this Mustang, the all-new Mustang, out of plastic here. 3D Systems is printing the same Mustang out of chocolate and out of candy.
The printer uses an inkjet printhead to very precisely paint water onto a dry sugar substrate where the model exists at that cross section. And then it spreads more sugar, it paints more water onto the sugar, and the water recrystallizes the sugar and allows it to harden.
A 3D solid model comes into the computer, and then the software slices that up like a deck of cards, and it's sent out to this machine, and then this machine prints it one layer at a time on top of each other and then builds it back up into a 3D model. This is the finished model. It's got the same detail as the original Mustang in 4.5 inches in plastic.
We take that whole pile of sugar out and we basically brush it off like we're archaeologists and do a little mini dig, and we blow it with compressed air, and at that point the model is revealed for the first time. So that's kind of the magic moment when this thing that you've been staring at the computer screen for hours and hours becomes a physical reality that you can hold and eat. This is the first 3D printed car that you can eat. Historic.
So what do you think about this project when you have your chocolate Ford Mustang? Do you have a chocolate Ford Mustang? Did you taste one?
No, not yet. But I will try. I will take my time to try it.
So how important are those, let's say, fun projects also for you if you do that kind of candy stuff?
I think that it is important. I think it is very important to check which direction the ideas goes, and then it's also interesting. For us, maybe the feedback is also to see which direction we are going with this 3D printing process, because it seems like we now have this process, but actually we are using this 25 years old, and now we are searching where can we apply this process. So, and this is also interesting.
But basically it's not really a new thing, because 3D printing has been around, especially with Ford, for about 25 years. You're one of the pioneers at the
We
brand
bought
for that
the
one.
third printer that appears.
Yeah,
Third.
and recently you've also been investing in some startup companies who are doing this stuff.
Yes.
And the question is, I mean, if it has been around for such a long time and already been used for prototypes, we heard, for example, that the Focus RS, all of the different models that parts that made it for the RS were also 3D printed. The question is, why this kind of search right now? What has changed in 3D printing?
Yeah, the quality that was expected was here, and what was delivered was here. And nowadays, with the new machines, with the new materials, the quality is here. So the expectation for a 3D printed part now is exactly what the designers and the engineers want. Of course, for engineering side, we are not really there, because they are asking about materials that have the same performance like in injection molding, and unfortunately we are not there. But for a design perspective, we are there. So, and even better, you can even print parts that you cannot. All these buttons here, I cannot imagine in the past doing this with milling process.
There's even another method, so we have plenty of different methods for 3D printing, and it's called carbon 3D. And that is very interesting because we have a fluid raw material and then kind of model is drawn out of the fluid. Let's check out the feature film about that.
Ford's been using 3D printing for over 25 years, and we've been using it for everything from early concept prototypes to prototypes that are actually runnable and testable, onto some very limited production tooling.
We're the first automotive OEMs to work with Carbon 3D. What we're really looking for in terms of additive manufacturing here at Ford is to be able to produce directly functional parts to use in our vehicles. What we're doing here with Carbon 3D is that we're looking at the materials and actually helping to create engineering materials that would have those properties. In the typical SLA process, it's a very layered method where a layer of resin is put down and cured, one layer at a time. After the cure, the next layer is put down. In this process, we're able to cure the layer while maintaining a continuous liquid interface. So instead of having that stepwise layer by layer process, we're able to do it more continuously. So it can be done faster, and the properties of the part are not layered. They're stronger in both the printed direction as well as the other direction.
With this process, because it's so much faster than some of the other technologies, that will allow the engineers to shorten that time frame down, to do that iterative testing, get through it much quicker. And in the end result, that really means higher quality products and more cost-effective products for our customers.
So this method, to me, is the most, let's say, dramatic one. It looks like, really like magic. I'm thinking about Terminator 2, with the the Terminator became fluid and became steel, kind of. And so, what is this method at the moment used for?
This method is what brings new is it's a continuous process. There's a disadvantage from this process here is that SLA that you build one layer by layer. So you have always this. It's a process that stops, goes in X and stops and running. Okay, and this clip process is a constant process that you can decrease the building time.
So the question is, where are we actually heading to with 3D printing, both design and engineering-wise? Yes. Let's say, what would you wish for the future? And what do you think what is realistic in the next 5-10 years?
It's very, very difficult to talk about the future, especially for this kind of techniques. If I ask my father 10 years ago, he will never say that we could build these parts. But if I talk about the future, it's very difficult, especially with the markets nowadays. They are changing so fast that now new machines appearing, new process. Even you talking about this clip, so new ideas will come in the future. So it's very difficult. But what I can say now is that nowadays for Ford is developing new vehicles much more quickly through this fantastic technology, 3D printing technology that can deliver cost. Prototypes ready to use in a matter of hours. I think this is the big message.
So what do we take from today's interview and also from the current information? I think first of all, when you produce the final stuff, we feel like the steering wheel of a Mondeo Lineale, this is especially important to the designers of the 3D printing process. And if you talk to the engineers, then it's more important that you can produce the tools with a 3D printer, then produce the final stuff with those tools which you see initially in the first feature film. It's also a very interesting process. Ultimately, I think you agree to that. The 3D printing will change probably the whole automotive industry because we also have maybe decentralized factories, like not one factory where everything is produced or a lot of. I think it's really possible to have more factories maybe and produce smaller amounts of different stuff, maybe even individualize something for the customer, but still don't have so much cost.
Yeah, it's a good point of view, and as I said, speculation is a little difficult for me, especially to talk about the future. But the ideas will come, and for sure Ford will be there.
Thank you for the insight, and thank you very much.